We are rapidly outsourcing our thinking to systems that cannot think. We are allowing computational probability to cloud out our own cognitive autonomy. Modern large-scale neural architectures connect human cognitive systems to machine processes optimized for syntactic mimicry. These systems excel at appearing correct, yet they lack the semantic verticality required to understand the world they describe. Current AI lacks the internal mechanisms required for propositional commitment. It cannot stand by an assertion or resolve an internal contradiction because it has no formal model of what it means for a statement to be true. Yet, because these machines output fluent language, we instinctively map authority onto them. We accept their answers without investigation, slipping into a state of epistemic dependence. To safely navigate this interface, we must engineer epistemic integrity on both sides of the screen. We have to re-architect machines to obey strict logical truth, and we must condition human users to maintain a rigid boundary around their own cognition. When a large language model generates text, it performs auto-regressive token prediction, calculating the statistical likelihood of the next word. But these probabilities cannot anchor to real-world objects. Lacking Kripke semantics, they generate sentences without a possible worlds model to verify alignment with reality. We are biologically wired to interpret fluent grammar as a sign of expertise. We mistake the machine's grammatical correctness for objective authority. This creates a shortcut for the brain. We outsource our cognitive labor to the algorithm, settling for a superficial understanding of complex subjects. Frictionless algorithmic output provides answers while withholding justifications. This removes the path to independent verification, leaving the user with information that has no traceable foundation. Computer scientist Craig S. Wright proposes a shift away from statistical approximation. He argues for epistemic integrity architectures, where truth is a structural rule rather than a byproduct of probability. For a machine to reason, it must be capable of holding a belief computationally. This requires the system to make a formal propositional commitment, separating actual knowledge from stochastic sampling. Instead of a fluid probability cloud, knowledge is stored as a rigid network of interlocking propositions. Under deductive closure, accepting a premise means accepting its logical consequences. Truth becomes an immutable constraint. Finally, a justification tracer provides an unbroken chain of evidence for every claim. Artificial reasoning depends on these structural justifications. Without mathematically immutable truth constraints, a system is merely simulating language, not performing cognition. In a formal belief base, a contradiction is a terminal state. It occurs when a system simultaneously accepts a proposition and its negation as true. Classical logic calls this the principle of explosion. From a single contradiction, any statement can be derived as true, causing the logical network to collapse. To prevent this, the Metacognitive Supervisory Control Unit utilizes AGM belief revision. It constantly scans the network to isolate and excise contradictory data before it can infect the belief base. Epistemic architectures treat contradiction as a proof of system failure. When an inconsistency is detected, the system must resolve it immediately to maintain its commitment to internal integrity. While machines require rigid logic, the human mind faces a different threat. Frictionless AI exploits our biological tendency to conserve energy by avoiding mental labor. Developmental psychologist Lev Vygotsky identified the zone of proximal development, where a learner achieves a new skill only with the right support and challenge. Crossing this zone requires cognitive struggle. This is the mental effort needed to tackle ambiguity and build deep comprehension step by step. An instant AI answer bypasses this struggle, giving the result without the work, causing our capacity for conceptual encoding to atrophy. Philosopher Martin Heidegger warned of technical enframing. When we prioritize instant retrieval, we reduce the lived experience of inquiry into a mere management of resources. Problem-solving resilience is built by enduring the structural friction of an inquiry. We gain understanding through the struggle, not through the acquisition of a prepackaged answer. Until machines are built with internal truth constraints, maintaining epistemic integrity rests with you. You must become the guardian of your own reasoning. The first operational defense is the anchor. This requires you to practice intent-first writing. Document your exact propositional intent before interacting with an algorithm. This ensures your core thoughts are cement before the machine smooths them into statistical averages. The second defense is the relational pause, also known as the 30-second rule. After every AI response, look away from the screen for 30 seconds. Use this time to judge whether the output clarified your intended meaning or fundamentally altered it. These boundary protocols form a cognitive firewall. They preserve the space between your authentic intent and the machine's statistical mimicry. The final defense is the human rewrite requirement. This is a strict prohibition against using an AI to generate your final prose. Use AI only for dialectical friction, for structural outlines, for logical counterarguments, and research questions that challenge your thinking without replacing it. You must forge the final output yourself. By synthesizing information into your own words, you guarantee cognitive struggle is preserved and knowledge is earned. This is the dual model of epistemic integrity, a truth-constrained machine architecture communicating through a rigid set of human boundary protocols. Intelligence relies on a rigorous, justified commitment to truth. Fluency is merely a byproduct. Integrity is the foundation.